Hi viewers, in today's video we'll be talking about Newton Raphson method of solving equation. Newton Raphson method of solving equation simply means a general method in which you can get the approximate value of an equation. Equations that, when I say equations, I mean equations that looks complex to solve. For instance, if you are given x e raised to power x is equal to 0, solving this, you can't just get the value of x directly, if not the approximate value. That's if it really exists. So Newton Raphson method now just will help in solving this. So we'll be deriving the formula to solve the Newton Raphson method. So, to solve an equation, say f of x, you have to let it to be equals 0. That's the first step in solving an equation. You have to make it first to be equals 0. Now, a small change in that function is still equivalent to 0. What I mean is, x plus its delta x is still equivalent to what? 0. Because no matter what, if approximately you go to the solution is going to be 0, same thing as when the function is equals 0. So now we will be expanding this function that has its change using the word the Taylor's series. So I'll say this is a name, I shouldn't have a small letter. This is Taylor's series expansion. We have to have f of x plus delta x is equals, firstly, the function, which is f of x, plus the change, which is the x, f prime of x, plus the second change, that's d square x, f prime prime of x, plus we get the third, which is d cube x, f prime 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 of x. Sorry, this is supposed to be over 2 factorial. This should be over 3 factorial plus the rest. So now from this is the Taylor's expansion for x plus dx. So from here now we have to neglect the higher powers of the change and the derivative. So we are neglecting from here. I'm going to have f of x plus delta x f prime of x. I will let it to be equal to 0 because we said it in the first place. So this is equal to what? 0. I'm trying to get the change in x. I want to see the value of the change in x. So from here, I will make f of x to cross to the other side. I'm going to have delta f of x is equals minus f of x. That's making this to cross to the other side. So from here, I want to make the x subject of the formula. I'll divide it by f prime of x. So I'll be having delta x f prime of x over f prime of x is equals minus f of x over f prime of x, such that this can cancel this out. So from here, I'm having my delta x is equal to minus f of x over f prime of x. And from here, when we say change in x, it means final x minus initial x. So I can just call this to be x sub n plus 1 minus x sub n, because this is the last stage minus initial, because plus 1, this is the initial. Now this is equals minus f of x over f prime of x. From here we are trying to get the value of the final x. So we make x sub n plus 1 the subject of the formula. So I'll be having x sub n plus 1 is equals minus f of x over f prime of x this should be plus, because this is crossing to the other side, x sub n. But I'm having a negative here. I want to insert it in the equation. So I'm going to make this to be x sub n plus 1 is equals x sub n, because it's positive, minus, I will now say f of x over f prime of x. And this is the formula used in the Newton Raphson method to get the approximate value of an equation.